Okay, so welcome to human-computer interaction class this spring. Uh, I will first go over the syllabus-related material, talk about what you should expect from this course, what I will expect from you throughout the semester, what is the workload of the course, and things like that. And then we'll have a break. In the second hour, I'm going to talk about the history of human-computer interaction, especially these days with the Internet of Things and different. Excuse me. Can you mute yourself? Mute your microphones. Let me try to. Okay, I can mute everybody. All right. So if you have any questions, feel free to unmute yourself, as I said, and you may also use the chat box for your questions. So what I was saying was, I will talk about the history of human-computer interaction, and these days, human-computer interaction is a really important subject, especially when we have computing everywhere in our cars, at homes, with the Internet of Things, and the other computing getting smaller and smaller, being available everywhere, makes this even a more relevant topic these days. But unfortunately, we see not every appliance or every machine that is out there is designed with human-computer interaction or usability in mind. So the main purpose of this course will be to basically raise awareness among computer engineers, software engineers like you, to also see this side. How can you design things that are usable? What is usability? How can you test usability? What are the tools that are available for you to make usable interfaces? And I'm going to go over the course weekly topics, and I'm going to talk about these things. So here is the course website, which is also accessible from my personal homepage. Second degree programs schedules, they are always announced on our department website at the beginning of every semester on their announcements. It's in Turkish, but the content really does not have too much text. So you should look for this Tezsiz Yüksek Lisans programı, which means Masters Without Thesis schedule for Masters Without Thesis programs. So every semester, at the beginning of every semester, the program is announced here separately, because usually there's a confusion with the program name, since the Masters with Thesis program also has the same program code 571. Which courses are offered in which program is really confusing. I don't know why they opened up this non-thesis program with the same code. I don't know the reason behind it, but this really is a big reason for confusion at the beginning of every semester. So the non-thesis program courses, therefore, are listed here on our department's website, and their schedules are announced separately on this website. So you should check our department's website to see which courses you can take from computer engineering or software engineering, the non-thesis programs offered in our department, which courses are offered that semester in these programs. So this, as you can see, this semester we have these, but one of these courses, digital geometry processing, I think is going to be closed because not enough students registered to this course because of a lack of sufficient students. This course will not be offered this semester. But these are the courses, and as you can see, all of them are going to be online, as the university administration announced. Again, due to the pandemic, we are going to continue this semester. Everything is going to be online. And this is the course that I teach Fridays at 7, as you are here. We'll be meeting at also the courses that I give every semester. I list them on my personal homepage, which is also accessible directly from the department's website under faculty members, or you can directly search for Google. You can Google Tolga Can Metu Cenk, and it will lead you to my personal website. This personal website, I have a section called Courses This Semester. As you can see, these are the courses that I teach this semester. I'm not teaching the data mining course. Actually, Ayşenur Birtürk Hoca is teaching it, but officially the course appears under my name because she cannot be officially teaching a non-thesis department course. But therefore, I'm going to be, in order to make it also official, I'm going to be teaching 2 weeks in that course. The topic of clustering in data mining. I will be teaching clustering for 2 weeks in that course, but mainly Ayşenur Hoca will be handling that data mining course. She's going to organize the assignments, the exams, so she's the main instructor of that course. So that's why I didn't even list data mining here. These are the courses that I teach this semester. All right, so this is 542. You're here, and I will be using this Cisco WebEx system for all my courses throughout the semester. It's the same link. Just click on it. It's publicly available. You can join the lectures anytime you want. I mean, there's no, if you're late, 10 minutes, 15 minutes, half an hour, just click on the link and join. You can join in the middle of a class, okay? Don't worry about being late. You can also leave classes early if you have certain things to attend to. So feel free to leave, join anytime. All right, and feel free to interrupt me when I'm lecturing. Feel free to unmute yourself to ask a question or write anything you have in mind in the chat box that you see on the right-hand side on my screen. And tomorrow, for those students who are in the deficiency program, they are taking this 792, and tomorrow at noon, we are going to meet at the same link for this class, and I'm going to give information about this course tomorrow. Okay, so today it's human-computer interaction, and we also have a course website. In addition to the material on ODTÜ+, this course website that I was in initially gives some syllabus related information. This course website has only 2 pages. The overview page, which is this one, and the schedule page, which, I mean, these things, they don't seem as like links, but they are links. So overview and schedule. If you click on schedule, this is a tentative schedule website, which contains all the lecture slides that I will be using this semester. So the lecture slides of all the weeks are available for you to examine. And there are some readings. And now let me go over the syllabus, and the readings and assignments will be more clear here. Today, the goal is to go over the course conduct. And then, as I said, I will have a 10-minute break, and after that I will talk about the quickly go over the history of human-computer interaction, what it is, and what type of research people do in this area, in the human-computer interaction area, and things like that. Okay, the course, if you look at the course description, it gives an overview of next-generation user interfaces and underlying methodologies. So actually, the course is composed of two parts. The first part is the general human-computer interaction topics, which is not related to next-generation interfaces. The first part contains topics like, if we go over the schedule, like affordance, usability principles, the human factors, because human-computer interaction is an area, it's like an interdisciplinary area in which the human factors also should be taken into account, like cognitive aspects and things like that, the sensory limits. So we are going to talk about human factors, and then there is also the technological side of it. What are the interaction modalities? What technologies are available to us? And these days we have newer and newer technologies available, like speech. When I gave this course like 10 years ago, the speech modality was not that common, but these days people use the speech-based interaction more and more. It's becoming part of our everyday lives with uh, applications like in smartphones, like Siri or Amazon Echo in our at our homes. So things like these make speech interfaces part of our lives. So we are going to talk about the technological limitations and things like that. So this will be the second week. Then prototyping techniques again are the central component of human-computer interaction, because we are going to see a user-centered design methodology, a design pipeline, a design workflow which tries to get users, the real users, into the development stage as early as possible. And one way to do that is by building prototypes. So this is something really different in general software engineering disciplines. Maybe I mean, when you're just developing some kind of an application in your work, most of you work as software engineers. The main goal is what you usually do is you have this requirement specification that you agree with the customer. The customer, so that's the contract you have with the customer. The customer before the application even exists. You just say, I want this. The customer says, I want this functionality, this functionality, this functionality. So there's a list of functionalities and the requirements, and they are specified as specific as possible, as clear as possible. But usually, the customer gets the product at the end of this design. There may be some stages where you show certain portions of the product, but usability rarely is the concern in these requirements. Usually the main functions are the focus and whether the final product is going to be usable. We are going to see what usable means, what are the usability principles. For example, how long it's going a new user of this application, how long does it take for the new user to get accustomed to using that application, or how many errors the user makes when using the application. Usually, most of the time when users may make mistakes while using the application, we tend to blame the user. We have all these user manuals. The user should read the manual. We have training sessions. I mean, I'm sure many of you who are working in these software engineering companies, after you deliver some application, you have some training sessions that you train the customers. Okay, so there's training pages. Hundreds of pages of manuals the users should read. So in most of those cases, if something wrong happens with the usage of the application, we always blame the user. Okay, the user should read the manual. But sometimes the error, the mistake is due to a bad interface. Okay, the interface itself, good interfaces do not require hundreds of pages of manuals. For example, do you always carry with yourself a booklet of different banks when you go to withdraw some money from an ATM machine? For example, when you go on a vacation abroad, there are ATM machines also all across different parts of the world. Okay, so when you approach an ATM and try to withdraw some money, do you need a user manual to use that? No, right? I mean, where you're going to put your card into, what you're going to do, everything. I mean, the buttons. So it should be usable with no training. This ATM machine is used by elderly people, older than 80 years old, or people that cannot see very well, all these things should be taken into account when that system is designed. So the main purpose of this course is to raise awareness about this user-centered, usability-centered design. So it's not going to focus on the functions that are required in different programs, but these general concepts. So that's the first part of the course. So we are going to talk about these things. And prototyping is really central because user-centered design that kind of design tries to involve user in the design process. And one way to do that is by building prototypes and testing them. It's not the purpose of building a prototype is not just to show the user the prototype and saying, how does this look? Is it good? It's not the purpose. The purpose is to use it for testing usability. Certain functions may be mimicked, or we can trick the user to thinking that these functions are implemented within themselves. But prototyping, the purpose is we have the users use the application through this prototype, and while doing that, we make tests for usability. And I'm going to talk about what these tests are. That's actually the second week, the evaluating usability. These 2 weeks, prototyping and evaluation, really goes hand to hand, because when you have a prototype, you use it to evaluate usability. So we are going to have things like the predictive evaluation, interpretive evaluation, and different types of prototypes. The reason we have prototypes is that they are not like limited versions of the main application, main tool that you're developing. We have prototypes because they are faster to develop. They can be thrown away, okay, and you can test and see different alternative designs. So prototyping is much less cheaper than the actual product. That's why we have those. All right. So as you can see, these first weeks, they are really general human-computer interaction topics, and different user interface design paradigms, interface design rules, guidelines we are going to talk about in the 6th week. So after 6th week, we are going to now jump into next generation interfaces. For example, adaptive interfaces, interfaces that are aware of what the user is trying to do, intelligent interfaces. And this is an area that still needs development, because this is really difficult. How do you model user actions? How do you create user profiles? There's adaptive interfaces, or there's also adaptable interfaces, which allow the user to customize the interface. So we are going to talk about these. But starting from week 7, we are going into the next generation interface territory. Lots of artificial intelligence related or machine learning related stuff is needed, for example, for really nice adaptive interfaces. And if these are done bad, the user community tends to reject them very quickly. For example, 20 years ago, Microsoft Office, Word, for example, and the other applications came with an Office assistant, a paperclip that was popping up on the right-hand side, trying to say, are you trying to do this? Are you trying to do this? And if at those times when you search Google for Microsoft Office and paperclip, the first thing that comes was how to get rid of the paperclip, or that dog that tries to help you. That's like an adaptive interface intelligent interface that tries to help you, but it may be annoying. So it should be implemented really in a nice manner by taking care of. It has to be accurate, and it shouldn't interrupt the user's actions. Okay. Now, we'll have the midterm exam. I'm going to talk about the percentages of midterm and final. It will be an online exam, and I may even make it a take-home exam. No, it doesn't need to be take-home. So it's a very short exam, and you'll see the percentages of midterm and final at 20% each. So the exams will comprise only 40% of your total grade. The main thing in this course that will determine your, I mean, there 40% is not ignorable, it's also large, but we will have weekly reading assignments. If you see the first 6 weeks, for example, the technical content of this course is very little. So very little technical content up to this point. It's really looking at all these things at a higher level to raise awareness. But I just also want to show you that people are doing research in this area. There are some certain problems that require really technical work to make progress in these areas. So I'm going to have weekly reading assignments from which we are going to have quizzes every week, not starting from the third week. Next week, we're not going to have a quiz. So I will give you your first reading assignment next week. At the end of week 2, I will give you a reading assignment about these affordance, usability, and usability principles. And we will have a quiz the following week at the end of the first hour of the synchronous class. Okay, so at the end of the first hour, I'm going to make on AutoClass, I'm going to make the quiz available. It will be 2 questions, multiple choice, very easy to do in 1 minute. You'll be able to do that. So just before we go to break, you're going to answer these 2 short multiple choice questions about the previous week's reading assignment. And then we are going to go to our break and continue with the second hour. Okay, so the quizzes, there will be maybe 8 quizzes or so, 8, 9, depending on how we go in the semester. We will have 8 to 10 reading assignments and quizzes about them. The quizzes, as I said, the main purpose is just to make sure that you have read the paper. So we will have these weekly readings in this course. And you will do a term project, and not the term project in the program, but in this course. So this course has a term project, which you can also use if you develop something really nice. You can also use that later in your term project class, which is a separate class. Which you are required to take before you graduate. You can also do something similar in that class as well. Okay, or if you're taking the term project class together with this course this semester, you can do a single project in both of them and use that project for both classes. But here, what I require from the projects, I'm going to go over the slides to talk about the detail, but it will be mainly development of a next generation kind of interface, not the regular web interface or an interface, not a web application or a desktop application. I want you to experiment with interesting ideas that we can have in an interface. It may be an interface of a flash drive, USB flash drive, which is not non-existent. I mean, you may think about non-existing technologies, and in the project, you're not required to have a functional product at the end. The main purpose of the project is for you to develop different alternative interfaces as prototypes and have those prototypes evaluated by some user tests. The final project report is just going to contain, for example, I tried this interface and this interface, this alternative. For example, I did the same thing with speech and with gestures, and the speech interface was more useful in this manner, but the gesture-based interface was more the pros and cons of both different interfaces. So the project topic idea is free. You're free to decide on anything, but as I said, it has to be some kind of a novel or non-standard interface. I don't want the interface evaluation of a web page or a web-based application or a desktop application or a regular mobile application. But if you have a touchscreen mobile application, you may try maybe different gestures on that application. That will also be nice. or combining different modalities together in an interface using both speech and the other things. And you don't need to know speech APIs. You don't need to implement really a real application, as I said. Those speech-based interfaces can still be evaluated by using some prototyping techniques like Wizard of Oz prototyping technique we're going to see in week 4, which basically tricks the user into thinking that the user is interacting with the machine while the user is actually interacting with a real human being, which is behind closed doors. Prototyping, if it's not possible to implement those technologies, prototyping technique allow you just test the interface. Our goal is not to test the technology. We're not, for example, trying to test what is the accuracy of speech recognition or things like that. The speech technology is not tested here. When you're designing an interface, speech-based interface, that interface may be, for example, the list of tokens, the list of keywords that you will be using in that speech-based interface, or it will be totally a free speech-based interface. You can compare these two things, whether a free speech-based interface with no keyword spotting, a word spotting type of application, and versus a speech-based interface in which the user has to speak a number of tokens or keywords to interact with the application, things like that. So this was just speech is one modality. There's vision. We are occupied with cameras in our machines. Our cell phones also have cameras. So vision-based interfaces are also can be some project ideas, speech, vision, or different gestures on a touch screen, not just regular selection and things, but you can have different ideas. So it's really up to you. I have some example project final reports for you to get some ideas about what kind of projects can there be. For example, speech controlled packs, or here, let's read. And again, this is touch and speech input together. So using two things together, two modalities together. All these examples are speech-based. I will put some more examples here which are not speech-based. Yeah, these are all speech interfaces. So I will also put some examples, example projects here which are not necessarily speech-based interfaces. But here in the project, first, the phase 1 report will be your project proposal. By the mid semester, you will decide on what type of project you're going to be doing in the semester. And you're going to, the phase 1 report is just the proposal part. And you're going to submit what you have decided on, what kind of interface you're going to be doing, what kind of alternatives have you thought of, what are the interaction modalities, is it going to be speech-based, vision-based, or some other thing based. For example, we can also use things like there are certain, for example, how many steps you have taken in a day. So, for example, you can use the gyroscope or other sensors available within your cell phone as an interaction mechanism. Whatever sensors available in the technologies, you can use those in the project. I will talk about the project details when I go over the slides too. So yeah, so as I said, the next generation interfaces, there are three-dimensional interfaces, augmented reality also becoming a reality these days with applications available on mobile phones. But still, we don't have like see-through displays such as Microsoft HoloLens available widely. It's still under development. Or we have some failed projects like, it's not failed actually, but it may be considered failed financially. The Google Glass, for example, its aim was to be like an augmented reality application, but it really was a two-dimensional screen that is augmenting your real vision. We can also talk about virtual reality here, VR-based interfaces with all those different gadgets that to interact with. You can also make a project if you have a VR headset available in your home or in your company that you work. If there's a VR headset, you can also use that as a next generation interface and try to experiment with different interaction modalities. Okay. So yeah, speech-based interfaces, we're going to spend 1 week. So all these next generation interfaces, we're just spending 1 week in all of them. So we're just going to touch up on the main concepts. What are the main things that we should be careful about when we are designing these interfaces? And I will give examples like that. So week 11 says no class. I think it may be we have a spring break. It may be actually earlier than week 11. So one of the weeks we're going to, I think it's starting May 8th. Starting 8th of May, we will not have a class. Vision-based interfaces that try perceptual interfaces that try to track people, track gestures, emotions, face tracking, people tracking. So this is what vision-based interfaces are. So the second part of the course, as you can see, is more new technologies, next generation interfaces oriented type of content. Ubiquitous computing, this now has another name, Internet of Things, or ubiquitous means everywhere but invisible. So computing being available everywhere around us and being embedded in the environment. It hasn't become like the in 1980s or early 1990s, visionaries in this area thought that in the next 10 to 15 years, we will have walls in our offices that we can interact with. We can interact with bus stops. We can interact with different things. But the ubiquitous computing actually happened as smartphones and tablets that are available everywhere. Maybe ubiquitous computing is just became the smartphones that we carry these days, or maybe computing devices in your cars, at your homes. And we are going to talk about what future directions we may have, the role of artificial intelligence, networks, the Internet of Things basically is how these computing devices that are everywhere and invisible, if they communicate with each other in a seamless manner, how they can enhance our everyday life. So the main purpose of all these human-computer interaction research is to increase human life quality while we are interacting with these technological devices around us. Okay, so the visionaries in the 1950s wrote articles like, how can we augment the human intellect by these with the computer, for example. There is a very nice article named Man-Computer Symbiosis in 1950s, before there was internet, before there was the computers, before there were personal computers. They thought that be accessing information with the help of this new technology will actually augment the human intellect, and we are going to get better and better. We are going to solve problems more efficiently by accessing information. But these days, really, it's maybe questionable because just information available everywhere does not mean that you access that information in a more efficient manner. Today on the web, for example, there is lots of garbage too, which which of those information is useful? How can you collect useful information together to get knowledge, usable knowledge out of those is, I think, a research area these days too. Okay, so that's the summary of the entire semester. So this is what we will be seeing. And every week I'm going to, although we have this is a 3-credit course and we have 3 hours every Friday evening, most of the time I will not spend more than 2 hours. Okay, we will not go all the way to 10 p.m. because it's end of the week. Everybody is tired, and In anyway, the material that I have prepared and we are going to cover can usually be covered in 2 hours or so. Okay, so I will not spend 3 hours of your time every week, but it will change from week to week. All right, so this is the schedule. There is no fixed textbook. As I said, the main teaching material will be the lecture slides and the reading material that I provide, which will be like research papers from flagship conferences in this area. One of those flagship conferences is ACM SIGCHI, a special interest group on computer-human interfaces. So yeah, special interest group on computer-human interaction or interfaces. So this conference in 2011 is going to be in Japan. Probably it's going to be an online conference, but it's a really big conference. There are papers, hundreds of papers every year in this area. So designing for voice. Look at the imagine better futures, AI for the next billion, designing trans technology. There are webinars. So these are different events that happen. Okay, so recent paper highlights gesture elicitation, data scientists. Also, there are some data science issues too. User study on mixed reality, remote collaboration with eye gaze and hand gesture sharing. So this is really interesting. So there are some talks here, as you can see. This is the paper. So there will be the readings will be similar to this. Maybe this paper that I just showing on the screen may be one of your reading assignments when we talk about that augmented reality, virtual reality, 3D user interfaces, or it may be also related to vision-based interfaces because there's eye gaze and hand gestures. They are mostly vision-based interfaces. So we will be reading papers like this. So this appeared in CHI 2020. And as I said, there are many articles published every year there. And we will be reading articles like this. It should be like 8 pages or so. Let's see. So we will have these weekly readings starting next week. You don't have any reading assignments this week. I will give the first one next week. And yeah, we will have the quiz 2 weeks from now. Wow, either it contains lots of images or it's a really long paper. So it's still downloading. And yeah, it's 13 pages. And from Switzerland, a collaboration from New Zealand and Switzerland. Okay, so it describes, so I'm not going to read the paper here, but it describes the setup, what kind of user studies, experimental design. So I think this paper is a really nice paper. It shows how you can have, how you can test different alternatives. For example, one alternative is verbal only. The other is eye gaze, hand gesture, eye gaze together with hand gesture. So they evaluated 4 different conditions and they asked certain usability questions. And they took some measurements and evaluated, for example, task completion time. That's one thing that they can measure. Or they also perform, there are some quantitative measures that they use to compare these interfaces. There are also subjective questionnaires that at the end of each session, maybe they ask users of the system some questions, and they also evaluate these answers to see which one is more useful. Okay, so yeah, I think this is a nice paper that I can definitely let me save this on my desktop. And this will be, I think this will be one of the reading assignments this semester. All right. Yeah, we don't have a specific textbook, but these are some reference books. You may find some of the material that we will have on the slides. They're also included in these textbooks. Um, uh, Basic programming skills are required for implementation of the class project, but this is not a mandatory requirement because some of those prototyping tools we have these days, they need even programming. Okay, without programming, you may be able to build those prototypes and do the user tests. So this is not a very critical prerequisite. And at the end, our goal at the end of this course is to expose you, the students, to the methods and principles of these human factors to raise awareness in usability issues. After this, and by the way, the name is human-computer interaction, but that computer can be replaced with anything. For example, an elevator, actually human-machine interaction or human object interaction. You may think about this as a human object interaction. Even a teapot is something that you interact with. It has a handle that affords, handling it, carrying it, and we are going to talk about these, especially next week when we talk about usability issues. But just do not limit that computer part to a desktop computer or a smartphone or a tablet. That computer can be your refrigerator. It's your TV these days. We interact with TVs a lot. We interact with automobiles. Okay, so we interact with elevators. I have seen bad interface examples everywhere. Okay, so and your first assignment actually will not be a quiz. Oh, I will decline this. I'm not going to annotate here. I'm just going over these. But if you want to have some questions and if you want to annotate, write something here, please feel free to write down the chat box. So, yeah, what your first assignment is going to be observing your environment and find something with a usability flaw. Something wrong with its usability. So we are going to talk about those usability principles next week, and this will be more clear. And I will give you some bad user interfaces. So probably there's a website about this. Bad user interfaces, interface examples. Yeah, Apple Watch comes one of the bad user interface. 5 of the worst user interface disasters, or you'll see lots of examples because it's not easy to develop interfaces that are good. It requires lots of effort. Yeah, Apple Watch, Windows 8, BMW iDrive, most TV remote controls, the Apple Watch, the USS Winston's control system. I don't know what it's like. Oh, that's an actually control system of a yeah, it's actually it's basically a ship, a U.S. Navy ship. So this is just one of the blocks. There are images, bad usable. I will send you some links, okay? But the user interface, again, do not limit yourself only to desktop interfaces or applications. All right, yeah, the midterm and final exam are going to be 20% each. The class project that you will be working, you can also do your class project in groups of 1 to 4 people. Okay, you can do it individually. You can do it with a partner, 2 people, 3 people, 4 people. But if you're doing it in a group, in the final report, you should make clear who did what. How did you distribute the workload of the project among team members? That should be clearly indicated in the final project report. But as I said, it may be a group project or individual project. And the quiz is about reading assignments. As I said, I'm going to have about 8 to 10 quizzes. This is what I plan. And it will be 30% of your grade. I will use OttiClass regularly for announcing the reading assignments, for announcement of your grades in the grade book, and also midterm final exam will be on OttiClass. So for announcement, for grades, I will be using mainly OttiClass. Okay, so make sure you check your Meto emails regularly and not to miss those announcements. Okay, the announcements will come as email notifications to your Meto emails. So make sure you check those emails regularly. Yeah, please feel free to send me an email if you have any questions anytime. Now we can actually go over the lecture slides quickly, and then we are going to have the break. I actually mentioned most of the things on the lecture slides, so I'm going to quickly go over them to see whether we missed something. Now let me, maybe I can use the annotation now. Okay, so we have the course website, which is this. That I showed earlier. Okay, let me get back to this one. The main goals I already mentioned, but if you quickly go over that, at the end of the course, you will hopefully have some idea of what is meant by good design, about usability. What are the guidelines, models that can be applied to interface design, and you will know and have applied a variety of methods for involving the user in the design process, the prototyping techniques, and you will have this class project that you will also have an experience, all these things. It's basically the main goal is to raise consciousness, to be aware of these usability issues. You will not look at your environment with the same eye after this course. You will look at, for example, when you enter a class, one usability design flow, for example, in our classrooms, in our departments, especially, for example, in BMB4 or BMB3. If you're a new student, well, there's a question. Will you be grading the members of the groups as per their contribution to the report? It may be like that, but most of the time, the whole group got the same grade all the time. I never individually graded group members separately. If there was something missing in the project report about who did what, I just gave feedback to the entire group, and the group just replied me with the answer, and everybody got the same grade in a group. Okay, so I will not individually evaluate the members. Yes, now I was talking about the design flow in BMB4, which is, let me use this one. So here is the amphitheater. So, and there is the seats are here. Okay, the students are sitting here, and there are a bunch of lamps at the top. Okay, in a sequence of rows like this. Now, a big challenge when you have a room full of lots of lighting fixtures like this, lots of lamps, fluorescent lamps above. Usually there are multiple buttons at the door, at the wall right behind this, multiple buttons that open different doors. Now, usually it's not designed with the concept of mapping in mind. So mapping, for example, is a very important usability concept. Mapping is about the mapping between interface element and the function that it accomplishes. One of the best examples in mapping is the mouse. Okay, so mouse is actually the interface element is a two-dimensional, your desktop, your real tabletop, which is a different plane than your monitor's plane. But it's a very good mapping. When you're moving left to right on the table, the mouse pointer also moves left to right on your screen, but these are two different planes. But the mapping is so natural and so clear that even a second-year-old kid, when they take the mouse first time in their hand, they will know which way to move. For example, moving up and moving forward are two different things, actually, right? You're moving your mouse forward when actually your mouse pointer is moving up on the screen. But the mapping is so good that it's so natural, nobody thinks about this. So good interfaces are like this. You use the interface naturally without ever thinking about whether how to use it. The first time a third-year-old child sees a bike, the child knows where the handles are, where to put the feet, where to sit. The appearance of the bike tells us how to use it. A bike doesn't come with thousands of pages of manual to see you should put your handle here. You need to turn the handle right to steer right, for example. These things are natural, built within the interface. So good interfaces are like that. So the bad example that I was giving this mapping was, for example, the first switch is maybe lighting this row of lights. The second switch may be lighting this row of lights. The third one, this row of lights. Usually you find yourself most of the time randomly selecting different combinations of these switches to get the correct function that you're seeking. Okay, a good mapping here would be the left to right mapping of the switches on the wall could be mapped to front to backward organization of the rows. That would be a good mapping. Most of the times, probably electricians make this mapping, but sometimes there are lots of switches all around. Some switch is about the projector curtain, another is about the lights, another is about the windows. So this is what everybody faces every day in our everyday lives. Okay, we have interfaces all around. We have switches, we have doorknobs, we have machines, coffee machines. Yeah, another thing, you may probably give good examples on coffee machines, how to operate them. Fax machines, and we don't have fax anymore, but the photocopiers, for example. These things, when a machine has a lot of functionality, it's usually more challenging to put all of these in a single interface. But as your first assignment, I'm sure, and it's not this week, by the way, I will talk about it next week. I will give you the first assignment next week, but your goal will be to observe your environment and come with design flaws that are similar to this one. So we will be able to, at the end of this course, you will be looking at different things and find these faults in the interfaces. The mapping is good. The mapping is bad. The visual constraints are bad. You will judge interfaces with different usability criteria. Okay, so in user interface design, it's not just a software interface on a desktop monitor. Okay, as I mentioned, it's any machine, any object that we interact with, we will talk about usability in those. And the goal of human-computer interaction in general is to allow users to carry out tasks safely, effectively, efficiently, and enjoyably. So there is the psychological factors here. It's really a human-computer interaction. You'll see the papers we read. It's not always technical, but there are social factors that are involved in human-computer interaction too. So I went over the course overview already. I went over the grading. And yeah, a human-computer interaction is what happens when a human and a computer get together to perform a task. So we are performing a task and we do it together by using some technology. The task can be writing a document, calculating a budget, solving an equation, proving some math theorem, or driving, or looking for the best restaurant, nearest restaurant, trying to find the next movie to watch. All these things are tasks, and we do it with the help of a computer. Okay, so there are technological and human perspectives. I mentioned these, and we are going to try to think in this course beyond the mouse and keyboard modalities. There are touchpads, mobile devices, gesture, voice, motion, recognition, tracking. In terms of human perspective, we will talk about memory, perception, motor skills, attention, things like this. And really, it's a discipline concerned with design, implementation, and evaluation of the interfaces. So designing, implementing, and evaluating, these are the critical, and as you can see, it's in a loop. The prototype is evaluated over and over again to find whether it's usable or not in terms of certain usability guideline, usability goals. Yeah, so class project, these are the details of the class project that I talked about. We are going to, in the class project, you're expected to design, implement, and evaluate a user interface. The interface part is the main focus here. You're not required to develop a functioning, working application or a tool. The interface is the part that should be functioning. So the user has to be able to interact with it somehow. The underlying function may not be correct or real, but the interface part should be implemented. Part one, you're going to form your teams, or if you're going to do it individually, you can start thinking about different topics to work on. And there will be the first phase one reports is the project proposal, and it should fit in one of these main themes: speech-based, vision-based interfaces. Multimodal means mixing together different modalities, different communication channels. Mixing speech with keyboard, mixing speech with gestures. It may involve some intelligent interfaces using machine learning AI, gesture-based interfaces for mobile devices. So it should be some novel next generation like interface that you should think about as your class project. And this is you're going to write what you have decided on as your phase one report, and the remaining of the semester you will work on it. You will design at least two alternative interfaces with certain aspects. You shouldn't just focus on a single interface and try to make it better. In human-computer interaction, we design alternatives because different alternatives may be different in terms of usability. And as the developer, we may not know which alternative is the best. That's the reason why we design prototypes. The user actually, while using, the user also does not know which works best for them. Actually, they just give us this information while using that interface. Okay, that's why we don't just ask the user, okay, is this interface good? Is this interface bad? We don't ask the user these. We just make the user use the interface, and while the user is using that, we conduct tests to see whether the interface is usable or not. Your evaluation report basically will be your final report in the class project. Okay, so this was I described part one and part two, different alternative designs, different level prototypes, and you will be evaluating usability goals of these prototypes. The evaluation report will be your main final report. It can be 1 to 4 people actually. You may even have 4 people project, that's okay. And project reports and presentations, last 2-3 weeks of classes, I'm going to use it for project report presentation. You will be presenting a 5-10 minutes. The main idea is to share what you did with your class members. We will make these presentations again online on Cisco WebEx in my meeting room. I will give you the right to share your screen, and you will present it online here. Just a 10-minute presentation at most. And the project reports will be due the last day of final exams. Okay, so you will have a chance to work on your final reports until the end of finals. What makes a good project? If you have access to some real problem, real and domain experts and users in the application area of your choice, it will be a good project. If you're accessing interest, if you're addressing interesting human issues, for example, designing an interface for children, for specific groups of users, designing an interface for elderly people. These are some interesting human issues. Designing for people with disabilities. This will be nice, interesting project ideas. This will also make it reach for if you find a rich domain for design with different alternatives, you will not have difficulty in generating alternative designs. Okay, so it's time for a break. That's all I want to talk about course conduct and the syllabus related material. We will have a 10-minute break until 8:11 p.m. And after that, I'm going to talk about history of human-computer interaction quickly in 30 to 40 minutes. All right. Do you have any questions about the course conduct of this part? I hope everything is clear. Okay, I will stop recording now.